All right, welcome. Happy Friday. Doing some linear quadratic systems here. So this is going to be a parabola and a line. So let's just review. For a line, the first thing we want to make sure we do is get this in y equals mx plus b form. We want to identify m and b. Remember n, right, is rise over run, streets, right? And then b is our y-intercept. For the quadratic equations, we want to make sure we get it in standard form first. So make sure you get x squared all by itself, right? Well, not by itself. Get everything on the same side as a positive x squared. And then after we do that, we want to make sure we do our table of values, okay? So our table of values, at least 7. You may have to do more or less depending on where the graph is going and what fits. And then we got to make sure we label the solutions, and remember that the solutions are going to be points. So if you don't label the points where the graphs intersect, you haven't actually answered the question. All right, remember there's 3 types of scenarios that will happen. The first scenario is where the graph and the parabola cross twice. So there's going to be 2 points of intersection. Make sure you label both. Where they just touch, there's going to be 1 point of intersection. Okay, and where they don't cross, there is going to be no solutions. All right. So for our first one, we have this parabola, y equals x squared plus 2x plus 1, and y equals 2x plus 5. Now, what I would recommend is you graph them on your calculator first. There's a couple reasons why. Number one, I want to know where they cross and what the graphs look like. So even though they gave me this 10 by 10 grid, maybe they cross at like 15 or 12. The graphs have to intersect on this graph here, which means you may have to change the scale, okay? And you may have to just like make sure that you're graphing appropriately so that you see both intersections. So keep that in mind. Make sure you don't just graph one and then be like, oh, the line's not going to fit, okay? So we're going to grab our calculator here. We know it's x squared, and it's plus, get out of there, plus 2x, and then is it plus 1. And there's our first, so there's our parabola, okay? And then our line is y equals 2x plus 5. So we're going to press tab to bring that down, 2x plus 5. And there's my line. So, and that would be my daughter. All right, so we're going to click in the box here, just like Lucas showed us at one time. We're going to change this to 10, and you can see where the graphs cross. All right, so we are going to graph this. We'll go over how to get the intersections on this again later. So for our purposes, let's go back here. We are going to do our table of values for the first one. So I'm going to do my x, y table. I don't know why that is so big here, but it is. So x, y. Okay. Now for the parabola, we're going to go ahead and we can see, right, that the minimum value, the vertex here is at -1. So we can put that number right in the middle, and that's -1, 0 for that point. And then we got to put some points around it. So -2, -3, -4. I'm just going to shift those down a little bit because I don't have a lot of room here. So -1, -2, -3, and -4. We know this is 0. All right. And then we have 0, 1, and 2. So we're going to go Control T. Now this is going to give us both of the equations. So one way to get the intersection is just to check the table, right? Excuse me. And see where they're the same. So you can see they're the same at the point 9. So we know that there's a solution there. But we want to put -1 in the middle of our table and really get the value here. So 0, 1, 4, and then 9. So this is 1 and 1, 4 and 4, and then we have 9 and 9. Okay, and then we're going to go ahead and graph those points. All right, so we're going to go ahead and graph at -1, 0, 0, 1, which means we're going to go over 1 the other way and graph 1 at -2, 1. We got 1, 4, so we're going to have -2, 4, and then we got to go over 1 up to 9. So 1, 2, 3, 4, 5 at 9, and then over 1. All right. And then comes the fun part of trying to draw the graph again. So starting over here. All right. I think we do better than that. All right. So, Kate, some drawing music for you guys, if you can hear it. So there's our graph for our parabola. Our line, you remember, is going to have y equals mx plus b. So we know m is 2 or 2 over 1, and b is 5. So starting with 5 on the y-axis here, and then we're going to go up 2 and over 1 to the right, up 2 over 1 to the right, and you can see those 2 points there shared right there, down 2 over 1 to the left, down 2, and you can see that these are shared there. Now, it's extremely important that there are some times where the graph, like 2 lines, or if you have a system of linear equations, the graph and parabola may not intersect unless you draw these out. So it's important that you extend, okay, these lines, doing it again, all right, all the way out on the graph. So make sure you extend these guys all the way out on your graph here, okay? All right. So now that this is done here, we can keep going. We're going to make sure we do our arrowheads, especially if we're not off the graph here, okay? And technically, we don't have to label the equations because there's 2 different types of equations. But remember, we said get in the habit of doing it because if you are supposed to and you don't, you will lose a point, okay, on the exam. And we don't want to lose those easy points, all right? And then we also have to state the solutions. So 2, 9 is one, and then -2, 1 is the other. Make sure our x and y are labeled, okay? And there is a full credit graph. All right, okay. One more on the next page. So I encourage you, we'll take a look at this one together. Company is considering manufacturing plant, okay? Determine the weekly costs. So the site A is supposed to be y equals 3x squared, while the production of B is 8x plus 3. Where x represents the number of products in hundreds and A and B, we want to graph those 2 functions, and then we're going to answer these questions below. All right, so we can see that this is counting up by 2's, okay? And this is going over by 0.2's. So we have to be careful when we do our slope, how we graph this, all right? So make sure you're careful here. Okay, we'll start with a parabola first. So we're going to go back to our calculator. We're going to go to a new document, not my documents. New document. No, I don't want to save this. And ours is just 3x squared. So 3x squared. And we're going to want to go to the tab and go to our thing here. So we have to graph basically from 0 to 4 is where our graph consists of. I'm just going to make this a little bit smaller here. Yeah, let's go 100. Okay, so we have a little bit better visual. So on our table, y equals 3x squared, x and y. So we know we're at 0. We're at 0. 1 is 3, right? 2 is 12. 3 is 27. And 4 is 48. So, remember we said, we can also change, so we can change this. Now, here's what you can also do. We can either change the window this way, so we can maybe put like -1 down, right? We can go up here and change this to 50, and we can change this to 4, we can kind of see this graph a little bit better. All right. So what we're going to want to do now is press tab. So that's how you change your window to kind of fit the window you have. And we're going to type in the second equation, which if we remember is y equals 8x plus 3. Hi, Kate. And there's the second equation. Okay, so bring the table back up. Notice I had to get rid of the table to bring it back up. I can get the points this way. So this is one way to do it, is graph those points and then draw your line in. Okay, we have 8x plus 3. So I know that I'm going to be graphing my y-intercept at 3, which is in between these two numbers. I'm going to go back to big style now. So I'm at 3, my intercept, and I'm going up 8, right? And over 1. So this is 2, 4, 6, 8, all the way over 1. So I should be at 11, and you can see 1, 11. Oh, you do, huh? Okay, so I go up 8, over 1, and technically over 1, right? Not over 1, because this is 0.2. This is over 1. So what I might recommend is on your calculator that you just graph these points. 111, 219, 327. So 111, okay. 2 is at 19. 3 is at 27. And if we add 8 to 27, we should be at 35. What's up? All right. And then I'm going to take my straight edge. We're going to go yellow, and I'm going to draw that line that goes through there. Okay. Now, technically, it doesn't give me an interval, right? But we're producing products. We can't make negative products, right? So we're not going to go down to the left of 0 on the x-axis, but we can go higher than 4 technically. So we're going to throw an arrowhead on this way, but not down the other direction, okay? So same thing here with the x squared. So we know our table here. So we're going to go ahead and graph those points. So we got to do 0, 0, 1, 3. So 0, 0, 1, we're at 3. I'm going to make this bigger. 1, 3. 2 is at 12. 3 is at 27. And look at that, we got a common point here. And 4 is way up there at 48. Okay. Shrinking down to 100 for drawing purposes. And then we're going to go ahead and draw our line in. So try to stay through those points. Oh, not bad, guys. Not bad. And there we go. So once again, we're stopping at 0. Okay. Got our curve in. And then we can label our equations. So this is y equals 3x squared. And as long as you're not doing anything crazy, meaning like you're not, it doesn't look like you sneeze in the middle of this, so this line's not all over the place. You're going through your points and you're not way off. You're not, the line isn't going like way down there. We're going to be good. And y equals 8x plus 3. Remember, we have to label the intersection here. So we're going to label this as 3 and 27. And remember, each of these points represents something, right? 27 is the cost of hundreds of dollars. So it's $2,700. And 3 is the number of products. All right. So when it says below, state the positive values for x, which the production costs at the two sites are equal. The x value would be 3. So 3. Now, what this means is these lines will intersect over here somewhere again, but that's the negative value. So we can say the production costs are equal at, or when x is equal to 3. Explain how you determine my answer. We would say I graphed both equations and found the point of intersection. Okay. And that's it for that question. Oh, no, we got one more. Company plans on manufacturing 200 products per week. Which site should they use? So if we go 200, right, way out here, you can see after week 3 that this site, y equals 3x squared site, is going to produce costs, right? $100 more here. So we want to keep the cost down, okay? So we would want to use y equals 8x plus 3, which we want to make sure we talk about as site B, okay? So we would say the company should use site B as the cost will be lower, okay? Now I also could plug in 200, right? So I could do 3, right, times 200 squared, and I could do 8 times 200 and then plus 3. And I can see the difference in cost here. So that's another option. It's just plug it in and check it. All right, questions? That's it, guys. If it talks about the values, and one of the nearby questions talks about what does the intersection mean, just remember what the axes represent, and that'll help you determine what the variable means. All right, guys, enjoy your weekend. Stay safe and healthy. We'll talk to you guys later.